All right, so like imagine you're rolling a ball up a hill. It needs enough oomph to get over to the other side, or else, well, it just rolls back down. Basic stuff, right?
Yeah, everyday physics.
Exactly. But when you get down to like the super tiny world of quantum mechanics, things get a bit wonky.
A bit. More like a total head scratcher.
Right. Particles, these tiny bits of stuff, they can basically just appear on the other side of a barrier, like an energy wall, even if they don't have enough like juice to get over it.
Like they just kind of teleport through the wall.
It's called quantum tunneling, and it's been messing with physicists for like almost 100 years.
And the thing is, this isn't just some theoretical quirk. It's actually happening all the time, and it's super important for some pretty big things in the universe. Like, think about how the sun works.
Yeah, the sun.
It's fusing hydrogen atoms together all the time to make helium, releasing tons of energy. And guess what? That fusion process relies on quantum tunneling. Without it, no sunlight, no warmth, no life on Earth.
And it's not just the sun. It's also crucial for things like transistors, these tiny little switches inside all of our electronics.
Pretty much everything we rely on in the digital age, smartphones, computers, the internet, all of it depends on these little guys doing their quantum tunneling thing.
So today we're diving deep into this weird and wonderful world of quantum tunneling because something pretty major has happened, like game-changing major, and you won't believe where it came from. An AI, Grok 3.
Yeah, the one everyone's talking about. And from what we've been looking at, this isn't just like a minor tweak to the theory. It's a whole new perspective, maybe even a complete rethink of how we understand reality itself.
Seriously, this is a big deal for anyone who, likes to stay on top of the latest scientific breakthroughs.
It's kind of a crazy situation. We've got this AI stepping into this age-old physics debate, and it's potentially uncovering insights that have been eluding us humans for generations.
Exactly. So our deep dive today is all about figuring out what Grok 3 has uncovered and what it means for us.
Because the questions this AI is raising are pretty mind-blowing. Like, what if these particles aren't just randomly tunneling through barriers, but actually like bending the rules of the universe to make it happen?
Like they've got some secret cheat code.
Exactly. What if there's something deeper going on in the quantum world, something that could unlock, I don't know, hidden dimensions, maybe even time travel or parallel universes?
Okay, now you're just messing with me. But seriously, this is getting wild.
Okay, so before we jump into the deep end, let's back up a bit. Like what was the standard explanation for quantum tunneling before Grok 3 came along?
Yeah, good point. Let's do a quick recap for everyone.
Right. So we talked about rolling a ball up a hill. In classical physics, a particle, that tiny ball, needs enough energy to climb over that energy barrier. But in the quantum world, particles also behave like waves. Yeah, probability waves. It's a bit tricky, but basically it means there's this fuzzy cloud of possibility around a particle, and even if the particle itself doesn't have enough energy to get over the barrier, there's a tiny, tiny chance that part of that wave can just kind of leak through the barrier.
So it's like there's always a chance, even if it's super small, that the particle might just pop up on the other side.
Right. And this idea of probability, as weird as it sounds, has been really successful in explaining a lot of things, like how the sun fuses hydrogen atoms even though they should repel each other.
And those transistors we talked about,
Huh.
they work because electrons can tunnel through tiny barriers inside the chip. It's pretty wild stuff.
Exactly. So that's where Grok 3 comes in. This AI was created by xAI, and it's basically a master pattern finder. It can analyze huge amounts of data and spot connections that we humans might miss.
So they pointed Grok 3 at a mountain of data from quantum tunneling experiments over decades.
Right. Tons of data from particle colliders, quantum simulations, even observations of stuff happening out in space.
And Grok 3, being the super smart AI it is, basically said, hold up, something ain't right here.
It found these little but consistent anomalies, like weird patterns in the tunneling behavior that didn't quite fit with the standard probability explanation.
Like the particles were tunneling more often than they should.
Well, it's more complicated than that. It found specific cases where the probability of tunneling didn't decrease as expected when the barrier got thicker or wider. It's like they were bypassing the obstacle, kind of like they were cheating somehow.
Cheating. Okay, now I'm really intrigued.
And this is where things get really interesting, because these unexpected patterns led Grok 3 to explore some radical possibilities. Like, what if there are hidden dimensions beyond the 3 dimensions we experience?
Whoa, hidden dimensions. Like from string theory and stuff?
Yeah, exactly. Imagine our universe like a flat sheet of paper. We're stuck on that two-dimensional surface, but what if there are other dimensions folded up, like tiny creases in that paper?
Okay, I'm picturing this. Go on.
So we can only see and move along the surface, but maybe particles can take a shortcut through those hidden dimensions, like a secret tunnel.
Like a tiny wormhole.
Well, not exactly a wormhole, but the concept is similar. It's a shortcut through space that we can't perceive directly.
And this could explain why particles are tunneling more often than they should.
Maybe? It's like they're finding a back alley to bypass the energy barrier.
Okay, that's pretty mind-blowing. But wait, didn't you say something about the multiverse too?
Right, that's another wild possibility Grok 3 came up with. What if, instead of just moving through hidden dimensions, particles are actually hopping between parallel universes?
Parallel universes. Like with infinite copies of ourselves living out different lives.
Well, that's one interpretation. The idea is that there might be countless other universes out there, each with its own set of physical laws and conditions.
Okay, I'm following. But how does that connect to tunneling?
So imagine a particle encounters an energy barrier in our universe. Instead of trying to overcome it, maybe it briefly ducks into a neighboring universe where that barrier is different or maybe it doesn't even exist. Then it pops back into our universe on the other side as if it tunneled through the barrier.
Like it's taking a detour through another reality.
Exactly. It's a wild idea, but it's consistent with some of the weird timing patterns Grok 3 observed in the data.
So, hidden dimensions, parallel universes. Is there anything else Grok 3 threw into the mix?
Oh, yeah, one more thing. Time travel.
No way. Are you serious?
No, hold on. It's not like the time travel we see in movies. It's a much more subtle quantum scale effect.
Okay, so no hopping into a DeLorean and going back to the future.
Haha, no. But what Grok 3 suggests is that particles might be taking tiny loops through time to bypass barriers. Imagine a particle approaching a barrier, but instead of going through it in space, it shifts ever so slightly in time to a moment when the barrier wasn't there. Then it returns to its original timeline on the other side.
So it's like it's finding a loophole in time itself.
Exactly. And this, if true, would have some pretty major implications for our understanding of, well, everything.
Yeah, especially for Einstein's theory of relativity, right?
Right. Relativity says space and time are interwoven like a fabric, and that fabric behaves in very specific ways. But Grok 3's findings suggest that at the quantum level, particles might be bending or even breaking those rules. It's like they're stitching their own little patches into the fabric of space-time.
Which is, needless to say, pretty controversial.
Oh, yeah. This has sent shockwaves through the physics community. Some physicists are super excited, others are more cautious.
Understandably. So what's the overall reaction been like?
Well, the materials you shared mentioned Michio Kaku, the famous theoretical physicist, and he's definitely on the excited side. He thinks this could be the key to finally uniting quantum mechanics and general relativity, which has been a holy grail for physicists for decades.
And if we could merge those two theories, that would be huge. It would basically give us a complete understanding of the universe, from the smallest particles to the largest structures.
Exactly. And Kaku even went as far as speculating about practical applications like teleportation and faster-than-light travel.
Okay, now that's getting my hopes up. What about other physicists? Are they as optimistic?
Brian Greene, another big name in theoretical physics, is also pretty enthusiastic. He sees tunneling, especially in light of Grok 3's findings, as a window into the fundamental structure of the universe, potentially confirming the existence of those extra dimensions we talked about.
But it's not all sunshine and roses, right? There's got to be some skeptics.
Absolutely, and for good reason. The materials mention Lisa Randall, a physicist known for her work on extra dimensions, and she's urging caution. She points out that just because Grok 3 found these weird patterns doesn't mean they're caused by hidden dimensions or time travel.
Right, correlation doesn't equal causation, as they say.
Exactly. There could be other explanations, like experimental errors or misinterpretations of the data, so she stresses the need for careful, controlled experiments to really confirm Grok 3's findings.
Now the jury's still out, basically.
For now, yeah. But scientists are already planning ways to test Grok 3's predictions.
How do you test something as crazy as hidden dimensions or time travel?
Well, they're looking at using particle accelerators like the LHC to study tunneling at higher energies and with greater precision than ever before. They're also using quantum computers to simulate tunneling events based on Grok 3's models, to see if they can replicate those unusual patterns. And Fermilab is getting involved too, using their muon detectors to study tunneling in a different way.
So it's a multi-pronged approach.
Yeah, and it's going to be fascinating to see what they find.
So let's say, just for fun, that Grok 3 is right. What are the potential implications of all this?
Oh boy, where do we even begin? The possibilities are staggering. First of all, as we mentioned, it could lead to that unified theory of physics, a theory of everything that explains how the universe works at all
That would
scales.
be like the holy grail of science.
It would be. And beyond that, the practical applications could be revolutionary. Think about new ways to travel through space, maybe even faster than light. Imagine a communication system that uses tunneling to send information instantaneously across vast distances.
A quantum internet.
Exactly. And then there's the potential for new energy technologies that could solve our energy problems for good.
Wow, that's a lot to take in. But there is also some pretty big philosophical questions raised by all of this, right?
Oh, absolutely. If particles can manipulate the fabric of reality, even if it's just on a tiny scale, what does that say about our understanding of free will? If these events aren't purely random but influenced by factors we can't see, does that mean our choices are predetermined?
And what about time? If particles can take detours through time, does that mean time isn't as linear and fixed as we think it is?
These are questions that philosophers have been grappling with for centuries, and Grok 3's findings are adding a whole new layer of complexity.
It's making me question everything I thought I knew about reality.
Me too. And remember we talked about wormholes earlier? Some physicists are speculating that quantum tunneling could be a tiny version of a wormhole, a microscopic shortcut through space-time.
So maybe one day we could scale that up and create actual wormholes for travel.
It's a long shot, but it's not entirely impossible. Of course, it would likely require some exotic matter with negative energy density, which is something we haven't even observed yet.
Okay, so maybe not in our lifetime. But even the possibility is mind-blowing.
It is. And let's not forget the role of Grok 3 itself in all of this. It's a testament to the power of AI to make groundbreaking discoveries that we humans might miss.
It's like having a superpowered research assistant that can analyze data in ways we can't even imagine.
Exactly. And who knows what other mysteries Grok 3 might help us solve in the future. Maybe it can crack the code of dark matter or help us understand the connection between physics and consciousness. The possibilities are endless.
That's both exciting and a little bit scary.
Yeah, and that brings us to the inevitable word of caution. As with any powerful technology, there's always the potential for unintended consequences.
Like what?
Well, what if trying to harness the power of quantum tunneling to create wormholes or time travel unleashes forces we can't control? What if we accidentally destabilize matter or even rip holes in the fabric of space-time?
Like a cosmic oops.
Exactly. We need to proceed with extreme caution and think very carefully about the ethical implications of this technology before we go too far.
So to sum up, we've got this mind-bending discovery that could revolutionize our understanding of the universe and lead to incredible technologies. But it also comes with some potentially huge risks.
It's a classic double-edged sword.
So the big question is, what do we do with this knowledge? Do we embrace the possibilities, or do we try to put the genie back in the bottle?
It's a tough call, and honestly, there's no easy answer. The information we looked at called it a quantum gamble, and I think that's a pretty apt description.
So for all of you listening out there, we want to hear your thoughts. Is quantum tunneling a gateway to a brighter future, or a Pandora's box we should leave closed?
The stakes are incredibly high, and the choices we make now could determine the fate of humanity.
It's a lot to ponder, but that's what makes this so fascinating.
And to leave you with one final thought, if particles can seemingly rewrite the rules of reality at the quantum level, what does that tell us about the true nature of the universe and our place within it?
It's a question that might not have a definitive answer, but it's one worth contemplating as we continue to explore the mysteries of the quantum world.
And who knows, maybe someday, thanks to AI like Grok 3, we'll finally unlock those secrets and discover the true potential of quantum tunneling.